Hello Geometry, this is lesson 4.1. Our objective is to learn about triangle sum properties. Before we jump into triangle sum properties, we need to remember how to classify triangles. Remember, we can classify triangles by their sides and also by their angles. For classifying by sides, if they have no sides that are the same, we say it's scaling. So if there's no congruent sides. If there are two congruent sides, or at least two, meaning if there's two or three, then we could call it an isosceles triangle. And then if there's all three, it's also an isosceles, but more specifically, it's called an equilateral triangle. An equilateral triangle where all three sides are congruent. If we're classifying them by their angle measure, it'd be if all three angles are acute, then we say it's an acute triangle. If one of them is right, then we know it's a female triangle, a right triangle. That's if there's just one right triangle. The next one is if there's one angle that is bigger than 90, meaning it's obtuse, then we call that an obtuse triangle. It's also worth noting that it is impossible to have a triangle with more than one right angle. If you don't believe me, try drawing it. And same thing with an obtuse triangle. Try to draw a triangle with more than one obtuse angle. And see if you're able to accomplish that. And then the last form for naming by angles, if all three angles are the same, we say it's equal angular. And most of the time when we're classifying triangles, like if it just says classify the triangle, we do that both by sides and by angles. A little bit more terminology. If we're talking about angles on a triangle, most of the time we're talking about those interior angles, the ones inside the triangle, and we call those interior angles. But there are also exterior angles that we get whenever we take a side of a triangle and extend it. We get this exterior angle, which we call exterior angles. So any side, if you extend it, you get an exterior angle. Side that one there. So there's like 6 different ones. Those two would be the same length. Those two would be the same length, same measure. Those two would be the same measure, and those two would be the same measure. Now, if you were to take a piece of paper and make a triangle, doesn't matter, any type of triangle, obtuse, right, acute, scaling, isosceles, anything like that. If you were to tear off the 3 corners and place them together, they would fit together perfectly to make a straight line. Well, if they form a straight line, that means those 3 must add up to be 180 degrees. And that is exactly what Theorem 4.1 states. It says the sum of the measures of the interior angles of a triangle is 180, and that's for any type of triangle. So if you add up those 3 interior angles of any triangle, it will always equal 180 degrees. So we're given an example here where we need to find the measures of each of those angles. Well, we have 3 angles here, so I know that x plus 3x plus 60 must equal 180 degrees. And that's because those are the 3 angles of a triangle. So x plus 3x is 4x plus 60 equals 180. Subtracting 60 from both sides, I end up with 4x is equal to 120. When I divide by 4, I get x is equal to 30 degrees, or x is equal to 30. So that means the measure of this angle here is 30 degrees. The measure of this angle is 3 times 30, which would be 90 degrees. Now, a corollary is another kind of theorem, but that ties directly to a theorem. So notice this one is called the corollary to the triangle sum theorem. So this theorem, or this corollary, comes directly from here. Now, we know that all 3 angles in a triangle add up to 180. So if it's specifically a right triangle where one of them is 90, I would know that the measure of angle A plus B plus C is equal to 180, but I know angle C is 90. So like if this was 90, I could subtract 90 from both sides and I would know angle A and angle B would add up to be 90 degrees. And that's exactly what this says, except for it uses better mathematical terms. It says the acute angles of a right triangle, so these two acute angles in any right triangle, are complementary, which remember means that they sum up to 90 degrees. Alright, the other thing we wanted to look at is an exterior angles of a triangle. Now we remember that we just learned that if we take the three angles inside a triangle and add them up, measure 1 plus 2 plus 3, then we're going to get 180 degrees. We also know that if we have a straight line with two angles that make up that line, we call those a linear pair, and we know that linear pairs are supplementary, or that they sum to 180 degrees. Now if you look at these two equations, you'll notice that this part is exactly the same on both of them. So notice this part and this part must then be the same, right? Because the left-hand side equals 180, the right-hand side equals 180. So they both have that 3, the measure of angle 3. So that means the measure of angle 4, this exterior angle, must be the same as the sum of these two non-adjacent, or we call them remote, interior angles. So this angle is equal to the sum of these two angles. And that's exactly what theorem 4.2 says. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of the non-adjacent, so the ones not next to it, interior angles. So if I want to find the measure of this angle 1, I say that one plus that one. So let's try an example of that real quick, where it says find the measure of angle 1. So we're looking for this interior angle actually, but first we're going to have to solve for x. So I know this outside piece here is going to equal to the sum of these two. So I'm going to say 40 plus 3x is equal to the 5x minus 10. So I'm going to add 10 to both sides and subtract 3x from both sides. 40 plus 10 gives me 50. Those two go to 0. 5x minus 3x is equal to 2x. Those two go to 0. Dividing by 2 gives me x is equal to 25. And so then this angle here we know is 40. This one is going to be 3 times 25, which is equal to 75 degrees. Then we can go back to our triangle sum theorem. I know 40 plus 75 plus the measure of angle 1 is equal to 180. Adding these two together, I get 115 plus the measure of angle 1 is equal to 180. Subtracting that 115. Those go to 0. Borrow 7, 15, 10, 5, 6. So the measure of angle 1 is equal to 65 degrees. Your homework is on page 111. You're going to do 1 through 6 all, and 6 through 36 even.